All right, ladies and gentlemen, welcome back. Here were the problems you were supposed to do on your own. This here first one is a cube root function. So it's going to have that curve that goes up in two different directions. This is a 1/4 as my a value, which tells me that I need to go right 1 and then up 1/4. So it's just barely off the line there. And because this is cube root, that also means I need to go left 1 and down 1/4 to get that curve. Whoop. So how does the graph look? I'm going to have the top curve go like this, and it's not going to increase very quickly at all. Because of how close this is to the line, it's going to really squish down. And same with this one, it's going to really squish down and become very flat. Okay? The dilations are going to flatten that out. It's still going to go on for eternity in both directions. It's just going to do it very, very slowly. Okay? This second one is a square root function. So I'm starting at 0, 0. And my dilation here is that -2. So it tells me to go right 1, down 2. And a square root always curves just to the right. So I'm starting here, and I go off like that. So it's going to curve out, and again, go on for eternity in this direction. All right, so those were our dilations. If you've got questions on those, make sure you address them, because you need to be able to do this to do the next thing, which is going to combine dilations with horizontal and vertical shifts. So the standard form of both square root and cube root functions looks like these two equations below. Now, I hope that you look at this and you recognize it, because it's just like the same form of the other functions we've done, right? There's our absolute value was like this, and like our square roots were like this, x minus h squared plus k. Notice the only thing that's changing here is the type of parentheses I'm using, right? Is it absolute value? Am I squaring it? Am I cubing it? What's happening, okay? This is the same thing, it's just the parentheses I'm using is a square root. But the h and the k work the same way. The a is the dilation, the h inside the parentheses is the horizontal shift. Note the negative sign, right? That's going to make it opposite. And the k is the vertical shift, which again is the same. So we can see where our graph starts based on the horizontal shift. And then we use a to do the right dilation for it. So let's do some examples here, okay? Notice this first one is a cube root graph. The cube root graph is going to, sorry, I got to get my color right. The cube root graph is going to be that one that goes up and to the right and down and to the left. Now, I notice that my a value is 3. My h value is -4 because it's opposite. And my k value is -1. Now, this tells me that I need to shift to this point, -4, -1, and start my graph there. So instead of at the origin, I'm shifting left 4 and down 1. And now I'm using my dilation of 3 to go right 1 up 3 and left 1 down 3. At this point, I fit my curve to the points. And I'm not worrying about perfect accuracy. We're getting the general shape down. If we were really concerned about being perfectly accurate, we would plug in some points to find out where this would be. We're just getting the general shape of it, okay? But that's it. I used my h and k to do vertical and horizontal shifts, and then I used of the starting point, and then I used my dilation to find out how tall or short it's going to be. Let's take a look at the second one. This is a square root function, so it's going to curve like that. I'm noticing that my a is -2, my h is +3, and my k is +2, which communicates to me then I need to shift to the point 3, 2. So my starting point, which is normally at 0, 0, is shifting to 3, 2 right there. I then use this dilation number, right 1, down 2, to determine the overall shape of the graph, which means I'm going to go down through that and curve to the right. All right, now you've got some examples that I'd like you to try on your own. Remember, it is possible for your h and k values to be 0, which means you're only shifting just up or just down. So keep that in mind when you're doing your examples. But go do those, and we'll see you back here in just a couple minutes.